Okay, so this is a fluid mechanics e-lecture, and so over the next 10 to 11 hours, whatever, we'll be discussing about some basic concepts in fluid mechanics, starting with some fluid basics. So whatever the topics which I covered will be fluid basics, and something about fluid statics, where you will get to know what is fluid pressure, what is the total force due to fluid pressure on horizontal, vertical, and curved surfaces. So these has application on dams, like how much forces are hydrostatic forces coming on the dam, and based on that you can design how much should be the base width of the dam from the structural aspect. And then we'll see about some basic fundamentals about fluid motion, basically the continuity equation, basically the conservation of mass, then the Bernoulli equation, the energy equation, and then the impulse momentum equation, on which all your jet propulsion, that is the basic behind jet propulsion. So so that will all come in fluid dynamics, and some basics about fluid kinematics, because you need to know how the acceleration, which approaches are used, Lagrangian or Eulerian, what is the difference, what is the, so those are basically control system and control volume approach, and how is the acceleration of the fluid particle defined. So all those things you in fluid kinematics, and type of flow, whether it's rotational flow, irrotational flow, when does rotational flow happens, when does irrotational flow happens, that is about fluid kinematics. And then some basics about pipe flow, and where you will study the viscous flow in pipes, basically how you will study about the Heisen-Poiseuille equation, how the Heisen-Poiseuille equation is derived, and what are the different types of losses, the major losses which occur due to friction, and the minor losses which occur due to the sudden change in the geometry. So all that in flow in pipes. Then some basics about boundary layer, where the objective is to calculate a drag force, say on a flat plate. That is a very simple problem, and keeping in mind that you want to get the drag force on an aeroplane, so that is what you get. So the entire boundary layer is all about getting the drag force. And then last and important topics about how your pumps, the centrifugal pumps work, and how your turbines work, Pelton wheel and the Francis, so all those stuff in turbo machinery. So this is all about the e-lecture fluid mechanics. Fluid mechanics is an important subject in the field of engineering. Okay, and it, so the objective, so as an engineer, my part in fluid mechanics will be to study how, when the fluid is at rest, I just want to know what are the forces it exerts on the structure. So basically it has two parts. The fluid statics part was these two, and the fluid dynamics was all this. So fluid statics applications are, the applications for the fluid statics are your calculating dam forces, forces coming on the hydrostatic forces first coming on the dam, so I can design the dam, how much concrete width to use. So hydrostatic, so if you have water like here, how much is the force, where is the force coming, what is the total magnitude of the force, and where is the force coming, because based on that I can decide how much should be my width of the dam so that it doesn't topple over. So all those stuffs, the application is hydrostatic force on the dams, on the gates, all that in fluid statics, and how your manometers work, all that. As an engineer, I'll be studying mostly about the effects of fluid pressure on fluid static. Fluid dynamics, the applications are, well, one of the main application is jet propulsion, where your impulse momentum equation, the change in momentum of the fluid is basically the force that is exerted by the fluid on the structure. So all, it's all about interaction between structure and fluid, and how force is transmitted from the fluid to the structure, or from the structure to the fluid, and how its momentum gets changed. So that is all about jet propulsion. So, and flow, and another application of fluid dynamics, so one is your jet propulsion. This is the basic principle behind all the objects that move in fluid, namely your aeroplane, your submarine, as well as so all those are basically, and your rocket. I mean, you want to move rocket in air or rocket out of the Earth's radiation field, you need to propel it. So that is the basic principle beyond all this is jet propulsion. Other application of dynamics is your, say I want to transfer water transfer water from say higher reservoir to a lower reservoir village level. So okay, how much should be the length of the pipe? Okay, so I'm using some length of the pipe, then how much is the discharge? So the discharge, that depends, the discharge, how much quantity of per second or per day I can supply, that basically depends on the difference in the heights of those two elevations. So all that water, city water transplantation, water transfer, or I would say water transport, that is the best word, water transport. All these are applications of fluid dynamics. So in the next 10 to 11 hours you will all basic stuffs about all this. So I'll cover all this, try to go as much detail as possible, and at the end we'll have, for each topics we'll have fluid, each topic in between you'll have all the some problems just to demonstrate the basic concepts, and at the end of each topic we'll have some gate problems which come in the last 10 years. So keep your fingers crossed and pay attention.